Hello friends, today we are going to see an important question from LeetCode. It's been asked by big companies. It's a frequently asked questions. It's called 62 unique paths. So let me read the description. There is a robot on an M and N grid. The robot is initially located at the top left corner. That is the grid of 0th row and 0th corner. The robot tries to move to the bottom right corner, which is nothing but the M of M-1 and N-1. That's the bottom right corner of the grid. The robot can only move either down or right at any point in time. So it just move one step, either from left to right or top to down. Given a two integer, M and N, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 2 into 10 power of 9. Let us take this example. The example 2 is a easy and easily understandable simple example. We have like 3 rows. M represents rows and N represents column, and we have 2 columns. So this is the 2 column, 3 row matrix. So how this robot can achieve from here to here, how it move from here to here is either it follow left to right, down, down, or top to down, down and right, or down, right, and then down. This is the 3 possible way. It can go right, down, down, or down, 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 right, or down, right, down. So we have to compute how many possible way that it can reach from left hand corner to right hand bottom corner. So this is a classic dynamic programming. So we just think of only one cells. Don't think of the big guy right now. So the dynamic problem, what we can do it in the dynamic problem is we just to break the big problem into small problem, and we just consolidate all the answers of the small problems so that we can achieve the problem of the big problem's results. Okay, for example, let us take if there is only one cell on the right, how this robot will move from left to the right. There is only one possible way. For example, this robot can move from left to right, this cell. If we have only down cell, this is the one cell, how the robot will move from here to here is there is only one way, from top to down. Let us take this diagonal cell. How many ways it can reach from here to here is either it move from left to right and down, or down and then right. There is a 2 possible way it can achieve this diagonal cell. It move from here to here. So similarly, we are going to compute the same concept. We are going to expand the results by adding rows and columns. And finally, we'll just represent how many unique ways it can reach from the top left corner to bottom right corner. Let us jump into code. And if you see the companies it has, is Google, Amazon, Facebook, Microsoft, Apple, Bloomberg, Adobe, like that. It's a classic dynamic programming. Let us declare the dynamic. So we have number of rows and we have number of columns. Okay, this is the dynamic array declaration. Let us talk about the first row. So the first row, the robot can only move from left to right. Like this column, it just have only one possible way. Either it can move from here to left to right, one step, one step, one step, one step, one step, one step. In similar way, you have the first column. It has only one possible way. It cannot come from left to right. It just go by top to down, one step, one step. So similar concept, we are just going to fill up the dynamic matrix. First, we will fill up the first row and the first column. We are just filling up the first row now. PP of 0th column. We will fill up this portion, like 1 down, down. Similarly, we are going to fill up the first row and all the columns on the first row column. Zeroth row, and we are going to fill up the column. So we just so far filled up the first column and the first row of the matrix, the dynamic matrix. Now we are going to fill it up the rest of the dynamic matrix. Since we already filled up the first row and the first column, we are just going to start from the index 1. So what I have written here is we are going to fill up the rest of the matrix. So row and representing the column for each column. So now either it comes from left to right one step or top to down. So CP of this represents the row from left to right of the same column, or the same row, but it comes from the top column to down column. So once we completed this filling up the matrix, we just have to return the final output of this portion. So we just found out how many unique fields that this robot can move from left hand corner to right bottom corner. Let me run this code and let's see. We got the runtime of 0 milliseconds. We got 100% and 0 millisecond faster than 100% Java online extension. And I hope you like this video. If you like it, please like it, share it, and subscribe it. Have a wonderful day. See you soon.